Hello, everyone. Today, I am pleased to present our work titled GSOT3D Towards Generic 3D Single Object Tracking in the Wild. Three-dimensional single object tracking, or 3D SOT, is a fundamental problem in computer vision. It aims to continuously estimate the three-dimensional bounding box of a target object across time, given its initial state in the first frame. This task plays an essential role in a wide range of applications, including autonomous driving, mobile robotics, and intelligent navigation systems. Over the past decade, remarkable progress has been achieved in this area, particularly through point cloud-based approaches. These methods have largely relied on autonomous driving datasets, such as Kitty and New Scenes, which have enabled the development of many deep learning-based 3D trackers. However, despite this progress, existing benchmarks impose several critical limitations that hinder the advancement of generic 3D object tracking. First, they contain a very limited number of object categories. For example, only 8 in Kitty and 23 in New Scenes, making them insufficient for training trackers with generalization capability. Second, they are constrained to traffic scenes, while a truly generic tracker should perform well in a wide variety of real-world environments. Third, these datasets only provide 7 degrees of freedom annotations, whereas real-world objects often exhibit 9 degrees of freedom variations in position, rotation, and scale. Consequently, current models remain far from being robust or generalizable for diverse 3D tracking scenarios. To overcome these limitations, we introduce GSOT3D, a new large-scale benchmark designed specifically for generic 3D single-object tracking in the wild. GSOT3D consists of 620 multimodal sequences, comprising more than 123,000 frames, and covering 54 object categories from both indoor and outdoor environments. Each sequence provides 3 synchronized modalities: point cloud, RGB image, and depth, allowing for single modal and multimodal tracking tasks. All frames are manually annotated with 9 DOF bounding boxes, following multiple rounds of expert inspection and refinement to ensure high accuracy. To our knowledge, GSOT3D is the largest and most comprehensive benchmark currently available for generic 3D tracking. To evaluate existing approaches, we assessed 8 representative point cloud-based tracking models on GSOT3D. The results indicate that all of these models experience substantial performance degradation compared to their results on existing datasets, highlighting the increased difficulty and greater realism of GSOT3D. This observation demonstrates the pressing need for more robust and general 3D tracking algorithms. In addition to the benchmark, we propose a simple yet effective baseline tracker called PROT3D, short for Progressive Spatial Temporal 3D Tracker. PROT3D employs a progressive, multi-stage architecture that refines feature representations over time through spatial temporal matching. Unlike most existing models that predict a 7 DOF bounding box, PROT3D generates 9 DOF predictions, enabling more precise target localization. Despite its simplicity, PROT3D achieves state-of-the-art performance, outperforming all evaluated methods by a large margin on GSOT3D. In summary, GSOT3D provides a powerful new platform to advance the study of generic 3D object tracking, and PROT3D establishes a strong and extensible baseline for future research. We hope that our benchmark, model, and evaluation results will encourage further exploration into robust, scalable, and generalizable 3D tracking methods for real-world applications.